Welcome to Unit 18, video number 2. This video will focus on redox reactions, or oxidation and reduction reactions. By the end of this video, you should be able to identify what element was oxidized and what element was reduced in a reaction. You should be able to identify oxidizing agents and reducing agents in a reaction. And you should be able to write oxidation and reduction half reactions. If you recall from our last video, we already have established that oxidation is the loss of electrons, and reduction is the gain of electrons. Remember, oil rig, oxidation is loss, reduction is gain. So in order to determine if electrons were gained or lost, we have to start by determining the oxidation state of every element in every compound in the reaction. Coming down here to this example, we know that sodium has an oxidation state of 0 because it's not in a compound and it doesn't have a charge. Likewise, chlorine has an oxidation state of 0. It's not in a compound and it doesn't have a charge. Over here, we see that sodium is in a compound, and we know from our rules that group 1 elements always have a positive 1 charge when they're in a compound. This means that chlorine must have a negative 1 charge in order for them to add up to 0, as they must in this neutral compound. Looking at our oxidation states, we see that sodium went from 0 to positive 1, meaning it lost a negative electron. Therefore, sodium was oxidized. Chlorine, on the other hand, went from 0 to negative 1. Therefore, it gained an electron, meaning that Cl was reduced. Essentially, if the oxidation number increases, the substance was oxidized. If the oxidation number decreases, it was reduced. Let's look at a bit of additional vocabulary for redox reactions. Often, scientists will refer to the oxidizing agent or the reducing agent. These terms can get a little confusing, but one way to think about it is to consider what a real estate agent does. A real estate agent is the one that causes the house to be sold. Just like an oxidizing agent is what causes the oxidation. Since it causes the oxidation, it must get reduced. Likewise, a reducing agent causes reduction. Therefore, it gets oxidized. In this example below, since sodium was oxidized, which we established on the previous slide, then that means that sodium is our reducing agent. It caused the thing that got reduced to get reduced. Likewise, since chlorine was reduced, that means that chlorine was our oxidizing agent. It was the agent that caused sodium to get reduced. Let's look at some examples and practice determining what was oxidized and what was reduced. Let's start by assigning oxidation states. Copper 2+, as we know, has an oxidation state of +2. Iron, because it's uncombined and it doesn't have a charge, has an oxidation state of 0. Likewise for copper. And Fe3+ has an oxidation state of +3. In this case, we see that copper went from positive 2 to 0, meaning it gained 2 electrons. This means that copper 2+ was reduced because it gained electrons. Iron, on the other hand, went from 0 to positive 3, meaning it lost 3 electrons. This means that iron was oxidized. Furthermore, since copper was reduced, That makes copper our oxidizing agent because it caused iron to get reduced or to get oxidized. On the other hand, iron got oxidized, so it is our reducing agent because it caused copper 2 plus to get reduced. Here's another example. Pause the video and try this one on your own before coming back for the answer. Welcome back. You should have started by assigning oxidation states to every element in each compound, as I did above in green. From here, we can see that carbon went from an oxidation state of -4 to +4. Therefore, it lost 8 electrons. This means that carbon was oxidized. We can also see that oxygen went from a charge of 0 to -2, meaning it gained 2 electrons. This means that oxygen was reduced. Since oxygen was reduced, that makes it our oxidizing agent. Since carbon was oxidized, that makes it our reducing agent. Generally, when we talk about agents, we actually use the entire compound that contains the element. Therefore, we would say the oxidizing agent is O2 and the reducing agent is CH4. Finally, we can represent oxidation and reduction through something called half reactions. This is exactly what it sounds like. We can write the half of the reaction that represents oxidation and the half of the reaction that represents reduction separately. Let's start with the oxidation half reaction. In this case, since tin went from a charge of 2 plus to a charge of 4 plus, it must have lost 2 electrons. So our half reaction for the oxidation part looks like this. We have Sn2 plus yields Sn4 plus 2 electrons because those electrons have been lost. The reduction half reaction, on the other hand, is going to deal with the gain of 1 electron between Ce4 plus and to become Ce3 plus. So here we have Ce4 plus 1 electron yields Ce3 plus. Notice that in oxidation half reactions, the electrons are products because they're being lost, whereas in reduction half reactions, the electrons are reactants because they're being gained. Let's look at another example. Pause the video here and try writing oxidation and reduction half reactions on your own first. Welcome back. In this case, we see that zinc went from Zn with a charge of 0 to Zn2 plus, which means it must have lost 2 electrons, making it the oxidation. Copper, on the other hand, went from Cu2 plus to Cu0, meaning it must have gained 2 electrons and was reduced. Again, our electrons are products in the oxidation half reaction and reactants in the reduction half reaction. This brings us to the end of this video. Let's quickly review our goals. First, we learned how to identify what element was oxidized and what element was reduced. Remember, when an element is oxidized, its oxidation number increases because it's losing electrons, and when an element is reduced, its oxidation number decreases because it's gaining negative electrons. We also learned how to identify oxidizing agents and reducing agents. The oxidizing agent is the element that gets reduced, and the reducing agent is the element that gets oxidized. And finally, we learned how to write oxidation and reduction half reactions. In the oxidation half reaction, electrons are being lost, so they're products. And in the reduction half reaction, electrons are being gained, so they're reactants.